Welcome back to the Rail Technology Magazine podcast, everyone. The show where we go beyond the headlines and get into the real complexities shaping our industry. I'm Roy Rowlands, and on this episode, I bring you a duo of guests I met recently at the rail industry's leading supply chain engagement event, Trans-City Rail. To set the scene, I was sat in an audience that doesn't impress easily and watched a room full of rail professionals genuinely sit up in the seats whilst they were watching a session called Trains with Brains, predicting the unpredictable, and the level of innovation on display was so striking that I knew before they'd even finished that I had to get them in front of our wider audience and dig into it properly. So I'm delighted to say they said yes, and joining me from Transmission Dynamics are Business Development Director Jenny Hudson and the company's founder and executive chairman, Professor Jarek Rosinski. And between them, they're showing the railway how AI and smart sensing can move us from reacting to failures to predicting and preventing them. Cameras with brains riding on the roofs of trains, catching faults the human eye could never before they ever become a problem. It's the kind of thinking that wowed the room in Scotland, and today we get to explore in detail for our wider audience. So, Jenny, Jarek, welcome to the podcast.
Thank you so much.
Thank you for having us.
It's a pleasure, absolute pleasure. So let's just jump straight into it then. But before we dive into the clever stuff, tell us a bit about you, Jenny. What's the path that led you to be Business Development Director at a company where building sensors for trains, wind turbines and defence is central to what you do? What pulled you into that part of rail?
Sure. So for the 15 years prior to working at Transmission Dynamics, I was supporting SMEs to grow through innovation. So I worked for Teesside University, and my role was to diagnose business challenges and provide support, whether it was grant funding, facilities, expertise to help them grow through innovation. So I thoroughly enjoyed it, met lots of different companies, got involved in lots of different technologies and projects. And I promised myself that one day when I found the right company, I would devote myself full time to that one company and try and apply my expertise to them. And then I met Jarek in Transmission Dynamics, and they just are, a standout company. From my whole career, I'd never met a company that drove such levels of innovation with such commercial impact for their customers. And so I spent a couple of years on a consultancy basis supporting the company, and then eventually came on full time nearly 6 years ago. Never looked back.
Yeah, it certainly sounds like you're hooked, and that certainly came across in the presentation a few weeks ago as well. Jarek, then you're a professor as well as a founder, and during your talk, you told a lovely story about being a student, putting your hand on a signal analyzer that weighted 20 kilos, watching a signal flip into the frequency domain for the first time, and I quote, not believing your eyes. Today, you unpack that whole analyzer into a tiny smart oil plug. Take us back to that moment. Is that the spark that became this company?
I don't think there's a single moment which created the business, but it was a gradual process, work in making. So quite a lot of my work initially was in academia. I was involved at the universities, and that's where I learned continuously, learning and perhaps teaching students. And that process allowed to acquire quite a deep theoretical knowledge. And it was only when I started to work at Newcastle University Design Unit, where we handled practical projects, troubleshooting, problem solving, where suddenly that fully advanced technical preparation converted into practical application, and that was a fantastic outcome, because combination of being eventually very practically minded, invited to problem solve to a number of industries around the globe with a pretty strong theoretical preparation, allowed to create something quite interesting.
Wow. So it's been a long journey. There's no such thing as an overnight success, right?
Well, sometimes you hear about people who suddenly drop from the university and next minute they are CEOs of the huge companies in Silicon Valley, and they are brave and all my. I wasn't that brave, but I still managed to stop the fear from stopping me from moving forward, which was a fantastic journey so far.
And the organisation has won some significant accolades and been shortlisted for a few as well. My next question is, I'd be interested to hear the answer from both of you actually, because you've won a few awards over the last 12 months, but you've just been shortlisted in the top 3 applications for this year's Royal Academy of Engineering Robert Award, which, if I'm right, is the UK's longest running and most prestigious prize for engineering innovation, and often referred to as the Nobel Prize for Innovation in the UK. How do you and the team feel about such a magnificent achievement? Jenny, what are your thoughts on that?
Yeah, we're always massively proud and privileged to be part of any awards ceremonies and accolades. It's great to have the team really recognised for the level of innovation and the impact of our solutions. But the McRoberts Awards is absolutely the Nobel Prize of Engineering. We couldn't be more proud to be at this stage of the process. It's a huge accolade, and we definitely think that the team deserves to be at this stage. So we look forward to the awards event. We'll see what happens.
Yeah, I'll bet. And what about you, Jarek? You know, as the founder of the organisation, you must be extremely proud of your own achievements as well as those of the teams.
Absolutely. For a long time, we were doing incredible amount of innovation in our previous offices, still in the same industrial estate, but we were enjoying ourselves. We were digging into the most practical and most advanced design programs, not really truly realizing how good the team become over time. I think that we had this privilege of being invited to do the troubleshooting, problem solving for others, and that's where we learned the most. So obviously the awards like this are fantastic. Saying that they're milestones, not destination, but seeing the recognition is a massive privilege, especially with the awards like King Award.
Wow. Yeah, huge achievements indeed. Let's dig into the story. Trains with brains. What is the bigger picture? I guess let's go to you with this next question, Jenny. Because the star of the Scotland story is Pandas V, your pantograph and overhead line monitoring solution. What is Pandas V in plain English, and why has it become such a flagship product for you?
Yes, as you said, we've got this wider portfolio called Trains with Brains, and the common concept there is having smart sensors installed on passenger trains to continuously monitor asset and infrastructure conditions to be able to prevent issues from occurring. Yeah. Pandas is specifically, as you said, looking at the pantograph and overhead line, so mounted on the roof of a train, and looking at the interaction between the train and the overhead line where we collect electric. It's become a flagship product because it's a turnkey solution that supports truly predictive asset management. So we are no longer requiring maintenance teams to download hours worth of footage to review what's gone wrong and change things for the future. We are doing onboard edge processing, sending alerts the second something starts to change in the system that might cause a fault moving forward. So it's been a massive step forward and a game changer in the way that people monitor these assets.
And there's been huge adoption. The numbers are striking. Around 100 systems deployed globally, monitoring up to 80% of the UK's electrified rail regions. A successful high-speed deployment on Eurostar, over 22 million kilometres monitored to date. When do you stand back and look at the scale, and what does it tell you about where the industry is heading?
Yeah, it's been hugely successful already, but the market is huge. Electrified rail is going nowhere. And really what it tells us about the market is that the industry is becoming increasingly reliant and expecting that kind of data-driven predictive maintenance approach, which is great to see. You know, these are things that we've been promoting for a long time. I think the things like COVID have made everyone realise that remote monitoring is essential, not just a nice to have. But we've definitely seen in recent years, in particular, a massive growth trajectory. And the opportunity is endless for this. We've seen, more complex, larger operating networks, more people operating across those networks, reasons to share intelligence and minimise disruption is needed more than ever. So yeah, we'll continue using Pandas to support that.
Oh, and one phrase from your talk really stuck with me: zero no faults found. Why is the fact that you always find something the headline rather than a worry? And what does that mean for your SaaS renewals?
Yeah, zero no faults found is a positive outcome. It's because the data is always delivering some real insights. So people would rather know that something is starting to go wrong than miss it.
Yeah.
And they would also rather know that it's a serious fault. You know, there is never an occasion where we send somebody to go and check an issue and they get there and realize that there isn't one. So being sure that the services we're providing are only producing accurate potential faults, this is what drives the value of the system.
Wow. Jarek, let's jump into some of the tech. Let's go on the roof. You've got a camera that sees the pantograph touching the overhead wire. Crystal clear, up to 4K at 60 frames a second, wrapped in sensors with a NVIDIA computer doing the thinking on board. Walk us through what it's watching and why doing the processing on the train rather than shipping video to the cloud matters so much.
I think that is all down to the speed of response. Historically, any cameras sitting on the roof of the train were CCTV, recording information onto the hard drive sitting in somewhere in the racks of equipment in the train. And then once recorded, the hard drives were physically removed, sometimes weeks later. That is too late. We obviously recognize that, and that's why we designed the camera, which not only transfers the information instantaneously, but transfers the information which is critical. And that's what prompted us to design the system with edge processing. Edge processing is processing on board. Obviously, we employed very powerful computing on board, but it's not just that, it's the combination of the sensors. You mentioned camera seeing. We've got a microphone so we can hear. We've got the accelerometer, which is sitting on the pantograph, wirelessly communicating with the camera, synchronizing the video image with impacts within milliseconds. Yeah. And then once that the selection of the sensors is combined, the power of processing on board kicks in. And that's where we can analyze on board. The camera decides this is a critical event and deploys the video within seconds. So that allows to change completely the way we monitor infrastructure and are able to respond. Instead of seeing the video a few weeks later and deciding, oh, we know what now why that incident happened. Yeah. We are sending this data instantaneously, allowing the key stakeholders to, in critical applications, stop the trains, remove the fault, and resume the in operation. And that is a game changer.
Yeah, I mean, one of the things that you said was at high speed, you wouldn't even blink, yet the camera freezes the frame and spots the broken dropper wire, those little wires joining the messenger wire to the contact wire. Why are those so safety critical? You described a chain reaction that can end with a live 25 kilovolts wire coming down. You know, talk us through that.
Yeah, it's actually quite easy to visualize. Messenger wire is this wire which is looking like a wash line from post to post, and that is designed to support otherwise absolutely perfect the flat and horizontal contact wire. That's where the pantograph draws the power. So if you look at trains like Eurostar, you would draw at 320 kilometers an hour, something like 13 megawatt of power, rain, wind. So it's a fairly substantial piece of equipment. Now, if you imagine that the contact wire is supported by those dropper wires of different lengths, forming what we call catenary, if you imagine that probability of failure of one dropper wire is 1 per 10 million, then it is very easy to see that even with that probability, we will see probably 2 broken wire a day. And here's the snag, because if the dropper wire fails, usually due to dynamic interaction between the pantograph and the contact wire, the line becomes slightly sagged, and that encourages even stronger impacts. And then the adjacent dropper wire fails. And if you have 3 adjacent dropper wires failed, you've got a significant sag, and then at high speed operation, pantograph collides with this overhead line, and very often causing significant issues. So the pantograph can be damaged, the overhead line can be stripped, that's called dewirement. And once you dewire at high speed, things are happening because you've got a 25,000 volts lifeline dropping on the roof of the train, hopefully very quickly resulting in isolation. But that causes significant disruption, that causes significant financial loss because of the subsequent delays and obviously replacement and repairs. So it is a critical piece of infrastructure.
And there was a story that you recounted, which you called iconic, at the event, the shattered isolator, I think, and that cross contact wire hanging dangerously low, where Pandas effectively predicted the next train would or could bring the whole thing down. And you said Network Rail rang you and said there was good news and there was bad news. Can you tell that story and what changed because of it?
Sure. There was a few stories, and obviously we now collected huge accolades of different case studies, and they're almost all very impressive. At a very early adoption, when we just deployed the Pandas system, there wasn't a system supporting handling the reports yet. It was being built at that time. And that was the time where Pandas system detected significant issue. We knew that that issue will result in dewirement of the next train. So we very quickly rang all our contacts. The system hasn't actually been automated yet to the point where you would automatically drop the pantograph, for example, at speed. So in all fairness, Network Rail reacted extremely quickly, but with the frequent traffic, however quick the response is, the next train comes minutes later and it dewired. Obviously, from our point of view, it was a spectacular case showing the power behind immediate, quick reporting and the power behind seeing that information and reacting. So we've got a few of those. Iconic case happened when we were delivering very interesting presentation in Cologne, and during our presentation, the reports came, and exactly the same story happened. We saw what's coming. At that time, we were actually in the middle of presentation, so we couldn't ring Network Rail, but I remember my mind when presenting was, will that be another dewirement? And it wasn't. The system was already in place. The system was already implemented, and Network Rail responded instantaneously. The trains were stopped, so there was some delay, but there was no significant consequential failure. And that is exactly what the Pandas is doing at its best.
Yeah, I mean, I hope the people listening to this and watching this on YouTube right now are really seeing what I saw and the rest of the room saw when in terms of the level of innovation thinking and just how significant an innovation this is. It's all making a lot more sense talking to you guys in a bit more detail.
I think so, especially that what is unseen is the technology behind, the use of AI. For many people, AI is transformers, GTP, the Chat GPT, and that's not the only fantastic use of AI. We are implementing both large language models, recurring neural networks to predict what's next based on the past history. But the most importantly, we teach the camera to be intelligent, to see, recognize images with the absolute certainty. So between the video frames sampling at 60 frames per second, we've got 16 milliseconds time only to perform a number of computations. So we are deploying a number of machine learning models between every video frame. And that's where the magic happens. The power we're delivering with this edge processing cameras supported by machine learning is just outstanding. We are surprised. We're surprising ourselves on weekly basis. So it is work in progress, but the progress is outstanding.
The audience was surprised, and the magic just kept on coming. And this is a good time to go back to you, Jenny, because as a joint presentation, I think when a customer gets on stage, people think, oh, this is the customer presentation bit. This is the sponsor. And from start to finish, that wasn't the case for you guys. It wasn't a marketing pitch. You let your client's own words do the talking instead. You had lots of stories like that, lots of evidence. And if we start with Network Rail Scotland, one of the things you mentioned, just within 3 months, they'd identified 104 detached droppers, 195 impact locations, and 3 critical faults. What does that early result tell you about Pandas being Scotland?
Well, the results in Scotland were typical, really, of all of our installations around the world. The system, the way it's set up, that from day one, you scan that route and you pick up all of the existing faults in one go. So there's a huge amount of value and data and intelligence being driven from day one. But then, of course, from that point, you're getting a continuous stream of evidence, of intelligence to help prioritise. And as Jarek said, some things are time critical. We've had installations. Just last month, we had one from Denmark. The second day the system was running, we prevented a dewirement. Like, there are urgent things that people can address from day one. From there, they can use the tools to be able to monitor issues, prioritize maintenance. And yeah, it allows people to manage their asset and infrastructure to increase reliability from day one. And Scotland's been exactly the same.
So Jenny, here's one then I think every cost-conscious leader will sit up for. Instead of physically patrolling the line every 8 weeks, Network Rail teams now use Pandas V as a virtual patrol tool and stretch that to every 26 weeks, saving around 2.5 million a year per region, if I've got my figures right. One region alone also recorded a 30% drop in high impact events, 17,000 delay minutes, and 6 prevented dewirements, can't say it, over an 18-month period. How does a virtual patrol safely replace boots on the ballast?
Well, essentially, we are providing continuous visibility. So there is less need to spend time walking the tracks looking for faults manually. So Network Rail, as you said, have now gone from doing manual patrols every 8 weeks to doing that every 26 weeks because they have Pandas scanning the network all day long, picking up faults. So essentially, it's reallocating resources from finding faults to resolving faults. And you can imagine, the business case quickly stacks up when you give support like that.
Yeah, definitely. But it doesn't stop there because they've got 3 more examples that, three saves that read like thrillers. You got Colchester where an accelerometer caught a googe in a brand new contact wire that would have taken out the Greater Eastern Main Line. That saved 1.5 million. Liverpool Central's Bishopgate Tunnel, the damaged section insulator no one knew about until Pandas V was switched on. About 2 million avoided. And the snap bridle you prevented from dewiring back in May 2025, all of all of them is the one that still gives you a chill.
Yeah, they are endless. As Jarek said, we have got catalogues of these examples. I presented those because they were the most recent. We attended an event for a new user, and that was within 8 weeks of having the system installed. This is what they were reporting back to the powers that be at Network Rail to say this is how we're using the technology. I would think the one that gives us the chill is the one that Jarek mentioned, being on stage and seeing those alerts coming all at once. It was actually, we had an impact alert, a broken dropper alert, and a height deviation alert all come through for the same location at the same time. And as Jarek says, we were literally walking on stage and thinking, crikey, we hope this is going to be addressed quickly. But it was also the most rewarding because having gone through that culture change process of a brand new system that people weren't necessarily paying urgent attention to, these alerts are now being prioritised by Network Rail, by the maintenance teams, by the train operating companies. If a report comes through, they act on it. So it was both the most chilling and also one of the most rewarding, I think, because we didn't pick up the phone and we didn't have to. It was all dealt with and we managed to avoid the fault.
Incredible. What a level of reassurance, I guess, for you guys, your team, but also your customers as well, to know that doesn't matter where you or your team are in the world, what are you doing? It's a slick operation, and essentially Pandas V kicks in and does what it was designed to do. Just want to touch then on Scotland. Scotland's only been, or rather, Scotland's been using you for a few months now. But what made you choose to come and speak about Pandas and the work that you're doing at Trans-City Rail Scotland? What made it the right place for you?
I think the audience in attendance, we were particularly grateful for the support that we had from Scotland, because they had a performance fund, a targeted performance fund, I think they called it, from the Office of Rail and Road, that allowed Network Rail Scotland to move really quickly. They were looking for funding projects that would support operational improvements to support their performance targets. And so from the very first call, it was something like a record breaking, it's like 6 weeks between getting that initial call, having the contract in place, which is unheard of with large organisations, and then being able to get the system up and running. We were up and running really quickly. The business case was proven, as we've shown, very quickly, and we're now already talking about rollout across the rest of Scotland. So I think we wanted to use the opportunity to kind of publicise the success of that performance fund as much as anything else, and the support that's enabled Network Rail Scotland to improve their performance.
But we see exactly the same performance and feedback from a number of installations globally. I think I may mention, because it's been widely publicized, that half of Denmark were paralyzed completely because of the derailment only a few weeks ago. And the demand for Pandas system was such that there was effectively the CEO to CEO request that need to be installed now. And then the first journey Pandas actually spotted and identified significant issues, which is phenomenal. I mean, the feedback from our clients globally is just outstanding.
Wow, yeah. And it just seems to get more futuristic the more I talk to you about it and the more you explain it. And Jenny, the intelligent pantograph network from prediction to prevention, this year you demonstrated networking the system so that the first train to spot a fault can warn oncoming trains to gently lower their pantograph for a few seconds past the danger spot and carry on. You said simply stopping trains was a big achievement, but not good enough for us. So how close is the railway heels around the problem in real time to everyday reality?
Yeah, it's close. From a technical perspective, the mission is completed. We have developed the hardware, the software, we've tested it and validated it. The functionality is there to be able to interact between Pandas and the pantograph. We're now in the process of gaining appropriate qualifications, accreditation standards, those sorts of things to allow customers to turn it on and access it. We're hoping, given that the potential wins from applying that kind of solution to the global rail sector, will help that be pushed through as quickly as possible. But yeah, that was somewhat out of our hands, but we are working closely with people to make sure that clients can get access to the technology. Because as you say, given the example we talked about in Cologne, we had this alert. Everyone was very happy and patting each other on the back when we managed to stop a train and prevent a derailment. But urgently your thoughts go to, but we still had to stop a train. There was less disruption than there would have been, but we still had to stop trains. So having this functionality to not only be able to identify faults, but be able to avoid them would be completely revolutionary. And we really hope to be able to get it to the market as soon as possible.
Wow. Jarek, you said AI is no longer science fiction. It's here, it's going to stay, and it's going to develop very quickly. And you closed on the idea of redefining the status quo 5 years out. What's the next leap for trains with brains?
Well, I think that the title of our presentation, Predicting Unpredictable, is very right. We don't know. I mean, the progress in AI and the sensor technology is so rapid that we just don't know what's just behind the corner. We are shaping the future. We are seeing the fantastic feedback, but where we are going to be in the 5 years' time, nobody knows. One thing is certain, that we are making progress. We are making fantastic use of the technology as it comes. And obviously, it's not just AI, it's not just software. The craftsmanship which is required to deliver these fantastic devices, which are whistling through, which are effectively fault-free, but above all, which deliver superb video quality. So you may have not noticed, but the wiper sitting on the front of the camera, it's not just a wiper, it's a wiper scraper, patented design, which allows to maintain this pristine condition of the video 24 hours in rain, snow, and wind, especially with the presence of the sticky carbon dust And we knew that it's required from ground zero operation. So when we started to design the system, we designed the system mechanically with fantastic seals, with a unprecedented set of sensors in the camera itself, from pressure sensors, humidity sensors, gyroscopes, accelerometers sitting on the roof of the camera. So the camera itself not only looks at the pantograph and communicates with the wireless accelerometer and decides based on the video, but it in its own is a fantastic sensor network which reports not just what is happening above the train, but also reporting sway, impacts, and those events pinpointing which we call right quality, where you have this sway where your coffee is typically spilled on the table. And sometimes the drivers report that by pressing the button and deciding this is the position, but it's all perception. We are doing these measurements. So delivering technology which is combination of superb engineering craftsmanship supported by what is continuously developing machine learning.
Wow. We're drawing to a close now, and I really love this conversation. There's been just so much innovation lifting off the stage at Trans-City Rail a few weeks ago, out of the presentation, listening to you guys just explain in a little bit more detail, well, in a lot more detail actually, because we've had a lot more time than we had a few weeks ago. It's been really interesting. I think the listeners rather, are going to really enjoy this particular podcast, certainly if you're an infrastructure owner or you're a trainer operator. But quick fun question to both of you, and I'll go to you first, Jarek. If you could bolt a brain onto one other thing in the railway that everyone's ignoring right now, what would it be?
Well, I think that it would be the Pandas camera, but it's not only that. We are developing this entire trains with brains. It's a accolade of systems. They cover the train monitoring and infrastructure monitoring from top to rail. So we've got the line scanning camera looking at the bottom of the train, and the wireless communication between the sensors, detecting, feeling, seeing, is the future. So I think that this is our best bet, and that's where we are developing.
What about you, Jenny? Have you got something in particular you'd like to bolt a brain onto in the rail industry other than Jarek's response?
Yeah, I suppose the natural progression, and one that we're working on at the moment, is deploying the trains of brain solutions from passenger trains to freight trains. So there's another huge market and opportunity to support there. In terms of the rail-specific portfolio trains with brains, we're looking at things like contact wire wear, solutions to support that in a more scalable, cost-effective way, as well as sort of track-based monitoring rather than overhead line and asset-based monitoring. So yeah, we're user requirements led, and the requests keep coming in. So we're doing our best to prioritize the highest demand and keep the solutions coming.
Jenny, final word to you. For an operator listening right now thinking we should be doing this, what's the single first step you tell them to take?
Absolutely, just get in touch. The first point of call is what we call our Suite Shop. Our Trains with Brains product page on transmissiondynamics.com holds all of the solutions, customer testimonials, great examples of detectable parameters. That's a great place to start whetting your appetite. And by all means, drop us an inquiry. Happy to talk.
I'll make sure all the notes all the links get put in the notes, and people can find everything that you've been talking about. I'll even put a link to the slides in there if you want, from Trans-City Rail, so people can get a little bit more context and start to visualize some of the things that you've been talking about. I think they'll find that really useful. Jenny, Jarek, thanks very much for your time. Thanks for jumping on this podcast with me, and look forward to speaking with you soon. All the best with the product development, and good luck with the awards.
Thanks so much, Roy. It's been a pleasure.